addition reaction, elimination reaction, or rearrangement reactions. Today we will study the substitution reaction. As during the substitution reaction, all of you know that one atom is replaced by another more active atoms or group of atoms. Depending upon the nature of the attacking reagent, the substitution reaction can further divide it as nucleophilic substitution reaction or electrophilic substitution reaction. If the attacking reagent is nucleophile, then it is known as nucleophilic substitution reaction, or if it is electrophile, then it is known as electrophilic substitution reaction. In nucleophilic reaction, substitution reaction, we are generally represented by Sn reactions as Sn1 reaction or Sn2 reaction. Sn1 reaction as for substitution and for nucleophilic, and 1 or 2 represent that it is the unimolecular or bimolecular. If 1, then unimolecular, if 2, then bimolecular. Now I am going to teach you the Sn1 reaction mechanism. Sn1 reaction is known as unimolecular. 1 means unimolecular nucleophilic substitution reaction. It generally takes place in the tertiary alkyl halide. Tertiary alkyl halide first undergoes ionization and form the carbocation. As here tertiary carbocation is formed, and formation of carbocation is the slow step reaction. Second step, where the nucleophile hydroxyl, here this is hydroxyl group is the nucleophile, it will attack on the substrate and form the product. So carbocation is very short-lived species, so immediately it will react by the nucleophile and form the product. Now this nucleophile attack takes place by 2 ways. As this is the tertiary carbocation, these are R1, R2 and R3 are the 3 alkyl group. Nucleophile hydroxyl group can attack from 2 sides. Either from the front side means where the leaving group attached or halide is attached, that side is known as the front side. Opposite side is known as the rear side or back side. So nucleophile hydroxyl group is attached either from this side or from this side, back side. So when it attacks from the same side where the alkyl group, where the halide group leave, that is known as frontal attack, and the product is formed as the same type of configuration. When the nucleophile is attacked from the rear side, then the hydroxyl group which is substituted to the halide group is attached on the back side, and 2 types of enantiomers are formed. In the racemic, so a racemic mixture is formed in which 2 enantiomers are formed in the ratio of 1:1. This is the mechanism of the Sn1 reaction takes place by the formation of carbocation. This step is formation of carbocation is very important. Sn1 reaction. Why it is called the Sn1 reaction? Because because here rate of the reaction depends upon only the substrate. This is the substrate molecule. So rate of the reaction depends only upon the substrate molecule, concentration of the substrate molecule. That's why it is known as unimolecular or nucleophilic substitution reaction. And it generally takes place in the tertiary alkyl halides. Sn2 reaction takes place in the primary alkyl halide where a transition stage is formed, and the rate of the reaction in Sn2 mechanism depend upon both the substrate and the attacking nucleophile. Concentration of both the substrate and the attacking nucleophile. So next is the mechanism of Sn2 reaction. Now Sn2 reaction mechanism. In Sn2 reaction mechanism, the rate of the reaction depend upon both substrate molecule and the attacking reagent. That's why it is known as Sn2 reaction mechanism. Here it generally takes place in primary alkyl halide. As primary alkyl halide, when attacked by the nucleophile, strong nucleophile OH minus, a transition state is formed where both the nucleophile attached with the center carbon atom, but hydroxyl group or attacking nucleophile being more or strong nucleophile, the electron drift shift towards the attacking nucleophile or OH group here, and the new bond is formed by breaking of this bond, CBr bond, breakdown, and the new bond COH bond is formed. Here you can see that the inversion of configuration takes place. His bromine group is attached here. Now the hydroxyl group is attached on opposite side. So inversion of configuration takes place. This inversion is known as Bolded inversion. This inversion or change in configuration is known as Bolded inversion, and this is the mechanism of Sn2 reaction mechanism. So there are some difference between the Sn1 reaction mechanism and Sn2 reactions. As first, in Sn1 reaction is known as unimolecular reaction mechanism because the rate of the reaction depends upon only the substrate molecule. Whereas Sn2 reaction is known as bimolecular reaction mechanism because the rate of reaction depends upon both substrate and attacking reagent. Next is Sn1 reaction is unimolecular reaction. Molecularity is or order of the reaction is 1. Sn2 reaction is bimolecular reaction. Order of the reaction is 2. This rate of the reaction depends upon the two things, substrate and attacking reagent. Third point is nucleophile attack takes place from both the side in Sn1 reaction mechanism. As we have seen that racemic mixture are formed 1:1 ratio. The attack of nucleophile takes place from back side also in the Sn2 reaction mechanism, an intermediate transition state is formed. This is the intermediate transition state is formed during the reaction where both the nucleophile is attached with the center carbon atom. So this is all for the Sn1 and Sn2 reaction mechanism. Generally, secondary alkyl halide undergo both Sn1 and Sn2 type of reactions because the activity of secondary alkyl halide depends upon the nucleophile, attacking nucleophile, that which type of reaction mechanism takes place in the secondary alkyl halide, whether Sn1 reaction or Sn2 reaction. It depends upon the nucleophile, attacking nucleophile. And Sn2 reaction mechanism takes place generally in primary alkyl halide, and Sn1 reaction mechanism takes place in tertiary butyl alkyl halide. Next is electrophilic substitution reaction. Next is electrophilic substitution reaction. This will be presented by ESE, substitution electrophilic. This substitution reaction takes place by electrophile. The strong electrophile generally replace the weak electrophile from the molecule, and the reaction is known as electrophilic substitution reaction. This reaction generally takes place in arenes and their derivatives. Arenes means benzene and their derivatives. As benzene when reacted by nitro NO2 plus, which is the strong electrophile, it will replace the hydrogen ion and form the nitrobenzene. In presence of concentrated nitric acid and concentrated sulfuric acid, when Cl plus group electrophile is attacked on the benzene ring, it also replaces the hydrogen from here in presence of concentrated H2SO4 and HNO3 and form the chlorobenzene Cl plus H plus, and when sulfur peroxide is attacked on the benzene, it will form the benzene SO2OH, benzene sulfonic acid. And when the methyl group is attacked on, alkyl group is attacked on the benzene ring methyl group, then it will form the toluene CH3. And all these reactions takes place on arenes and their derivatives. Friedel-Crafts reaction are also the part of this type of electrophilic substitution reaction. So this is the electrophilic substitution reaction and nucleophilic substitution reaction. Free radical substitution reaction takes place when the free radicals are formed, like chlorine Cl2 molecule break down in presence of either light or heat. Pyrolysis or thermolysis takes place and chlorine free radical is formed the alkyl group or alkane and displace the hydrogen atom from that, from the carbocation and from the alkyl halides. As this I will explain you just. Free radical substitution reaction takes place by the formation of free radical as halogenation of alkane. Here, halogen break down into the free radical either by the thermolysis or by the pyrolysis. Chlorine free radical is formed. This chlorine free radical attack on the alkane and form the alkyl free radical. So this first step is the initiation step. Second step, where the alkyl free radical is formed and which this alkyl free radical further react with the chlorine molecule to form another halogen free radical or another free radical. So this step is known as propagation step. And here the two free radicals are combined together to form the other new molecule. This step is called the termination step. So free radical substitution reaction takes place by three steps: initiation reaction, propagation and termination reaction. First step, the free radicals are formed, which is known as initiation step. Second is alkane change into the alkyl radical, and then further alkyl radical react with the halogen to form the another free radical. So this is the form of the this is known as propagation step. Last step is known as the termination step, where two free radicals combine together to form the new molecule. So halogen of the alkane takes place by the free radical substitution reactions. So this is all for the substitution reaction. Next is addition reactions. Addition reaction is the specialty of the multiple bond, double bond or triple bond, which contain the pi bond, either one or two, as in double bond and triple bond. At that time, the nucleophile addition and electrophilic addition takes place, and two types of reaction mechanism takes place. As first is nucleophilic addition reaction. This takes place generally in carbonyl compound. Carbonyl compound, due to the electrophilic effect, oxygen atom attract the electron towards itself and acquire the negative charge, and the carbon atom acquire the positive charge. And this is positively charged carbon atom is attacked by the nucleophile, like here cyano group, and attached here. This step is attack of the nucleophile is the slow step. Next step is the fast step, where hydrogen ion is attached to the oxygen atom and form the cyanohydride. Like this is the nucleophilic addition reaction, where nucleophile attack takes place on the carbon atom. Another type is electrophilic addition reaction. This is the specialty of the double bond or triple bond, like alkene and alkyne, aliphatic compounds. As in ethene or ethylene, where the bromine react, the double bond of the alkene or ethene are polarize the bromine molecule and develop a dipole moment in the bromine molecule and form a pi complex. Pi complex, this pi bond form the complex with the bromine molecule, and it will break down the bromine molecule and form the carbocation and the nucleophile Br minus. This nucleophile is very reactive and immediately, because carbocation is also short-lived species, so they both react together and form the ethylene dibromide. So the addition electrophilic addition in alkene and alkyne this takes place by this method. Free radical addition reaction also takes place, and that is by the Kharash, that is also known as Kharash effect, where free radical is formed which combine with the double bond and form the new species. Next addition reaction is free radical addition reaction. Free radical addition reaction generally takes place in unsymmetrical alkene, and it is known as Kharash peroxide effect, as addition of hydrogen bromide in presence of organic peroxide to unsymmetrical alkene. It is known as Kharash peroxide effect. It is anti-Marconi of group, as this is the organic peroxide. R the alkyl group. This is the organic peroxide. In presence of sunlight, it will break down thermolysis or pyrolysis. It will photolysis or pyrolysis. It will break down into the free radical. Here the homolytic cleavage takes place and two free radical RO are formed. RO free radical react with hydrogen bromide and it will change into ROH and bromine free radical is formed. Bromine free radical is very reactive, and when it reacts with unsymmetrical alkene, it will form two free radical, as this is the double bond. If the bromine radical is react here, then this free radical is formed, which is known as secondary free radical, and if the bromine radical is attached on this carbon atom, then it is this free radical is formed, which is known as primary free radical, and we all know that secondary free radical is more stable than the primary free radical. That's why the HBr, when react again on this free radical, then we get the propene, 1 propene, 1 bromo, propene as the main product, propane as the main product we get, and one more bromine free radical is formed. So because the secondary, this reaction mechanism takes place by the formation of free radical, as secondary free radical is more reactive than primary free radical. That's why the main product is the secondary free radical, and the main product depend upon the free radical, whether it is secondary or primary. As here in the Kharash peroxide effect, in the free radical addition reaction, the main product decided by the free radical. So secondary free radical is the most stable free radical. That's why 1 bromopropane is the main product instead of 2 bromopropane. So this is all for the addition reaction.